Hey, welcome back to Math with Patrick. Today is March 5th, and we have problem number 64 from this Daily Epsilon calendar to try out. All right, so ABX is a 3-digit number times X, which is a 1-digit number, equals another 3-digit number, and apparently A, B, C, and X are all different or distinct digits. So that means X could currently be anything between 0 and 9. So like 0, 1, 2, 3, 4, all the way up to 9. And I'm just going to write them all out so that as I kind of work through my thinking, I can cross off the ones that don't work as I go. And I'm hoping that I don't have to write it all out for A, B, and C, but we'll just see what happens. So the first thing I notice is this ones column here. Whenever you're doing multiplication, like say it's 132 times 2, like I'm going to be multiplying this 2 by that 2 to get my ones place. And what I notice here is that this right side digit is the same all the way down. It's x, x, and then another x. So I already know that 2 is not going to work because I don't get a 2 down here. I need to find a digit to place in the ones place so that when I multiply them, I get the same digit on the bottom. So just based on that, let's see. So if I try a 0 and a 0, sure, 0 times 0 is 0. Same thing with the ones. 1 times 1 is just 1. 3 times 3 is 9. So if I put 3's here, I get a 9 in this ones place. So this one doesn't work. 4 times 4 gives me 16. And so I'd get a 6 in the ones place. That doesn't work. 5 times 5 is 25, so that one's okay. 6 times 6 is 36, so that's okay. 7 times 7 is 49, and the 9 doesn't match with the 7. 8 times 8 is 64, and then 9 times 9 is 81. So I only have 4 potential digits just by checking that ones digit, the x times x, ending in another x in the ones place here. All right. Now, okay, we both know the answer is 5 because that's today's date. How about let's try the 0, the 1, and the 6 first, just to disprove those ones. And then finally, once we get to the 5, we can be very, very sure that that's the answer for today. So trying a 0 here, well, let's just see what happens. Okay, A and B have to be different digits, so maybe I'll do like 1, 2, 0. Okay. And then multiplying anything by 0 is going to get us, well, 0. So yes, the x digit matches, but I don't even have a 10 or a hundreds digit. So this one won't work just for the reason that multiplying by 0 doesn't it just gets a 0. It won't give us any digits here. So let's see. If I try x is 1, then let's just try a and b are like 2 and 3. Well, multiplying by 1 just returns the same number. So, but down here it's going to be 231 as well. And I notice here that A and C are supposed to be distinct digits. And well, when we're multiplying by 1, they're not. So for a different reason, this 1 doesn't work. So here, I'll say A equals C for this one as my reason to cross it out. And then I'll say over here that, I don't know, C and B don't exist for my reason to cross out the 0. Okay, so like I said, I want to attack the 6 first before I get around to the 5. Let's try what happens when x is 6. So x is 6. And then I said earlier, 6 times 6 is 36. So I'm already going to have this 3 to carry over. And okay, I need to make sure that b is the same digit as b. That's kind of my next step in all of this. So I need to pick b right here, some digit, so that when I multiply 6 times b plus 3, I get something with the same digit b in the ones place. So let me write that out. 6b plus 3 equals, well, some amount of tens and then another b. I guess, I mean, there might be a better way to do this, but I guess I just kind of have to run through all the numbers here. Like, I don't really see a way for me to just like quickly cross off 6 like I did for 0 and 1. So I guess we could just try it out. If b is 1, then I get a 9. Well, that doesn't line up. If b is 2, I get 12 plus 3 is 15. So the 2 and the 5 don't line up. Let's see. And it looks like I'm just adding 6 each time. So instead of like working through like the times 6 plus 3, I'll just add 6 to each of these. And that way my thinking will be a little bit faster. So here's 5, and then I'm going to add 6 to make a 33. 6, add 6 gets to 39. 7, add 6 gets to 45. 8, oops, I was going to say 61, but that should be 51. And then I'm going to stop at 9, again, because these are digits. I guess I should technically do a 0 here. 0 is a possible digit, and then I'd get a 3 right there. And there we go. So here are all of my digits, 0 through 9. And then finally adding this 6, I should get 57 here. And then just to make sure that like all my numbers are good, like following this plus 6 pattern, just making sure it makes sense. If I do plug in a 9 into 6 times 9 plus 3, I do get 54 plus 3 is 57. Okay, so this list makes sense to me. And just kind of running down the list, 0 and 3 don't match, 1 and 9, 2, 5, 3, 1, 4, 7, 5, 3, 6, 9, 7, 5, 8, 1, and 9 and 7. So none of these even line up. So that rules out the 6 for a different reason. Let's see. I mean, here I said A is equal to C. I'll just say B can't match B. And finally, we are now checking to see if 5 works. Well, it's the last digit, so hopefully I can produce these 2 3-digit numbers here using this 5 as X. And how about I'll just keep my work on the side right here, just to kind of keep this handy and show how none of those lined up for the 6. Okay, trying the 5, I'll put a 5 and a 5 here. 5 times 5 is 25. Now I will work on placing this digit B. And do I have to do the exact same thing? Like 5B plus 2, because that's the 5 times B, and then add the 2 that I'm carrying is equal to something with a B right here. And I mean, I don't see a good way to do this except just try out all the digits. So 0 goes to 2, and then here my right side is going to count it by 5s, and then on my left side it's going to count it by 1s. So 2, oops, that should have been a 7. Here, I'll do the right side first. 12, 17. Oh, so it's just going to go back and forth between ending in a 2 or a 7. So this would line up, and then since it always ends in a 2 or 7, I can just kind of skip on down to the 7. And it looks like odd numbers end in 7s and even numbers end in 2. So this one will actually end in a 7. And then plugging in the 7 back here, 5 times 7 is 35, plus the 2 gets me 37. So here are 2 potential values for B. B could be 2 or B could be 7, and those are the only values that work. So I guess below I'll put a 5, 5, 5, and then potentially a 7 and a 7 could match, or a 5, 5, 5, and then maybe a 2, 2 could match. And let's see what A and C are going to be. And these have to be distinct digits. So just making sure that this makes sense so far. 5 times 5 is 25. So I'll put the 5 down here, carry the 2. 5 times 2 is 10, plus 2 is 12, so I'll carry the 1. And then I need an A and a C. Over here, I would have carried a 2, so this would have been a 37, so I carry a 3. I get A and then C. All right. I think I want to do, I don't know which one I want to do first, honestly. Let's just try the one on the left. I don't really see anything else besides just trying out digits. Maybe I'll find a nice pattern with like how I found 2s and 7s over here. So let's see. 5 times A plus 3 must be equal to, well, just C? Yeah, just C, because if I have a bigger number, then I'll have a thousands digit, and according to the problem, this last number is a 3-digit number. So 5a plus 3 can only return me a 1-digit number. So let's see here. Maybe, well, a can't really be 0 because otherwise I only have a 2-digit number here, 75. A could be 1, and that would give me an 8 for C. So this seems reasonable. Maybe, here, I'll write it down here. Maybe I have 175 times 5 is equal to 875. I mean, that works. Great. Just making sure that nothing works over here. Let's see. 5a plus 1 equals C. All right. And again, C has to be 1 digit. And I can't pick 0 for A, but I could pick 1. And so I get a 6. Okay. 125 times 5 equals 625. And both of these statements make sense to me, I think. I mean, I'm just double checking. 5 times 5 here is 25. 5 times 7 is 35 plus 2 is the 37. 5 times 1 plus 3 is 8. And then this one I can kind of just do in my head a bit more quickly than the one I just said out loud. And did I mess up anything? My 1's digit is all the same. My 10's digits are both the same. And then my 100's digits are different. So it looks like actually there's 2 separate solutions that conform to the rules stated above. And either way you do it, x is going to be equal to 5. So actually, this is not what I was expecting. I thought we were just going to have one definite answer in the end for like what multiplication was going to happen. Seems like 2 work. But either way, x is 5. That's today's date, and we're all done. So, bye-bye.